Hello and welcome to my channel, The Complete CSC Guide, and I am Sanskriti. Today we are going to discuss about the HDLC protocol, that is the High Level Data Link Control, that is a data link layer protocol, as you can see in the figure. Okay, so today we will discuss about this one, right? So before we approach, let's first of all see what is HDLC. So high level data link control, HDLC, is a bit oriented code transparent synchronous data link layer protocol developed by the ISO, that is your International Organization for Standardization. Okay, so most important data link control protocol. So it is basically bit oriented. Okay, that is byte oriented and bit oriented, we all know. So it is basically bit oriented, and it is code transparent. Whatever code you are doing in this particular protocol, that is transparent, and it's a synchronous data link layer protocol. It is a very important data link layer protocol, as we will discuss about more protocols. So it is a basically it's a very important data link layer protocol, that is your HDLC, high level data link control. It is just for the controlling of your data link layer. We have already studied about the two types, that is the MAC and LLC. So it is a type of protocol which is used in the data link layer. Okay, now next, that is from where it had started. Okay, so from where this particular your protocol had started. So it is basically synchronous data link control, that is SDLC, by IBM. There was again a protocol, that is SDLC, okay, which was started by IBM, and from there it's the initiation of this particular protocol. Now advanced data communication control procedure, that is ADCCP, by ANSI. These are the basically two places from where we have uh, received this particular HDLC protocol. So here you can see a figure, particular figure, where from station A and station B, the whatever the packet that is exchanged using this HDLC. And here you will see in other slides you will see further that what are the different types of frames which we are using here. So basically here you can see the time. Obviously a time limit is there, as we have already seen in the previous that is the stop and wait, etc., etc. protocol. So you have seen there. Now here we will be seeing some flag, some type of synchronization, some type of your uh, construction, how we are going to show the particular frames. U frame is there, I frame is there. So here some particular data, a particular sequences there. Okay, so that particular sequence we will see in the next slides. Okay, so basically it had came from this particular SDLC and ADCCP. Now what are the basic characteristics of this particular protocol? It is primary station, for the primary station from which it's leaving. So it is responsible for controlling the operation of the link. Whatever operation will be happening within this particular link for the primary station, this particular SDLC is responsible for controlling that operation of the link. Okay, then it handles the error recovery. Whatever error is there, the error recovery system is being handled by this HDLC. Okay, so this is also a function of your, or it's a characteristic of your HDLC protocol. Now frames issued by the primary station are called commands. So whenever the frames are issued from the primary station, that are known as commands. Okay, so this is basically is for the primary station, means from where the frames are leaving or the frames are being issued. Okay, next is your secondary station, who's receiving. So it is operates under the control of the primary station. Obviously it will control, it will be controlled totally by the primary station. So it is the that the operations, whatever things are being going on in the secondary station, that is being controlled by the primary station. Okay, now frames issued by a secondary station are called responses. Since the primary station, it is giving the your particular commands and it is giving the response. So primary station will give the command to the secondary station and the secondary station will obviously give a response. Okay, the primary station maintains a separate logic link with each secondary station. So each and every secondary station, the primary station is establishing a particular separate logical link. Okay, so separate logical link is being established by the primary link with the secondary links. Okay, so and combined station, combine the features of both primary and your secondary station. So in between these, when we are combining these two, obviously the both of them are having the combined characteristics of the primary as well as your secondary station. Okay, now here you can see the figure where two link configuration had been shown. This is your primary station, this is your secondary stations. Okay, so here you can see the primary station is maintaining a logical link with each of the secondary stations, which is individually. Okay, now this is unbalanced mode where the primary station is giving the commands and the secondary station is giving the response, but it is in a unbalanced mode, right? So two kinds of modes are there, one is unbalanced and one is balanced. So this one is the balanced mode where we are combining both of them. So it is a combined version, which is a balanced one. Here what is happening, the commands and responses, they are going on, okay, simultaneously they are going on. But here why it is an unbalanced one, since you can see the primary station is obviously it is linked with all the secondary stations individually with a logical link, but still you can see the command once going when from where the response is coming, because the command to which particular station it is sending and the response is coming to the. So this one is an unbalanced mode, but when we are talking about a balanced mode, so where the thing is combined. Okay, so here you can see the combination of both the command and response, they are going on simultaneously, right? So this is basically the two types. Now three data transfer modes are there. In this particular thing, the data transfer modes, there are three kinds of data transfer modes. One is the normal response mode, that's your NRM. Okay, so in normal response mode, what is happening, used with an unbalanced configuration. It is done when the configuration is unbalanced. At that time this NRM is used. Okay, so primary may initiate data transfer to secondary. Here what will happen, the primary may initiate the data transfer to the secondary. Okay, so the initiation is being done by the primary station. Okay, now but secondary may only transmit data in response to a command from a primary, but the secondary station, it will only give a response when it is getting a particular command from a primary station. So it will give some response against a particular command. So basically the secondary will only give a response when it is getting a particular command. Okay, so in that particular case the secondary station will give a response. So NRM is used on multi-drop lines, the lines where there is multi-drop lines. At that particular time this NRM is being used, that is your normal response mode. Okay, next is asynchronous balanced mode, that is ABM. Okay, so it is used with balanced configuration. In case of balanced configuration means the combined procedure, we are using this particular ABM. As the name suggests, an asynchronous balanced mode, so obviously it is for the balanced mode. Okay, then either combined station may initiate transmission without receiving permission from the other combined station. Since these stations are combined, okay, so here what is happening, either of the stations may initiate the transmission without receiving permission from the other station. Since it's combined in nature, so it can, anyone either can start the or initiate the transmission. Okay, so here the without any permission, either one can start the particular initiation of the transmission. Okay, either combined station, any combined station can start the transmission. Okay, widely used, it is used widely. Okay, efficient use to connect from one device from one another. So it is mainly efficiently used to connect from one device to another device. And now second is the asynchronous response mode, that is ARM. Obviously used with an unbalanced mode, it is not given that balance, so it is used in unbalanced mode. And the secondary may initiate transmission without permission of the primary. Here the secondary station may initiate the transmission without taking permission from the primary. So here the secondary will initiate the transmission. First one, normal mode, the primary may initiate the data transmission. in next ABM, that is the asynchronous transfer mode, balanced since either, and in asynchronous response mode, there the response it's been initiated by the secondary one. Now, these are the three data transfer modes which are used in this HDLC. Okay, I hope you have understood. Now the next slide we will see the frame structure of HDLC, that what was I was talking about. Okay, so here you can see the whole frame structure of your HDLC. Now you can see first one is the flag, which is 8 bits. We have already seen that is of bit oriented one. First one is the flag bit, which is 8 bits. Okay, next is the address bit, which is again 8 extendable. It can be extendable, and control bits 8 or 16. It's also extendable. Information bit, particular information that is your flag, address, control, and the information where you can that particular can be variable. Okay, variable in nature, and FCS that can be 16 or 32 bits, and again the flag bit, it will be of 8 bits again. So it will be starting with a flag bit, and again it will be ending with a flag frame. So this is the particular frame structure of your HDLC. The frame format, that is information, supervisory, and unnumbered. These are the three types of frames which we will be talking about in our next slides. Now you can see here how we will be making this flag. Okay, so sorry, particular frame structure. So here you can see the numbers and how the format, field format are being structured. So this is a particular field format. Now you can see how we have defined. Okay, so there is some sequence number, some receiver sequence number, some sending sequence number, supervisory function bits, etc, etc. So basically the nature of this particular thing, that is your which field will have how many bits, it is being shown here. That flag field will be having 8 bits, address field again 8 bits, that can be extendable also. Control field will be 8 or 16 bits, it can be also extendable. And information particular field can have some variable kinds of bits, variable number of bits, and FCS will be having 16 or 32 bits. And again the flag field will be having a 8 bits. So this is the format, or this is the frame structure of your HDLC. Now let's talk about the flag field. What is that? Okay, so flag field frame contains unique pattern at both ends. Okay, so unique pattern will be at the both the ends. So it is for the uniqueness, it's for the just to see whatever thing is there in the first flag field, that will be having some uniqueness with the next flag field, that is the starting and ending flag fields will be unique. Okay, no assurance of occurrence of same beat pattern somewhere inside the frame. So in somewhere inside the frame there is no assurance that the occurrence of same beat pattern will be inside the frame. There is no such assurance given. Okay, so but our flag fields are unique pattern. Both the ends whatever flag field are there, that will be of unique pattern. But in between no assurance is given that the flag fields, or sorry, the fields occurrence of same beat patterns can be there. There is no such particular assurance is given. Okay, inside the frame, not the flag bits, inside the frame, the other bits. Okay, other fields. Now bit stuffing is used, original pattern is given, this one is your original pattern. After bit stuffing the pattern will be like this. Okay, so this is basically the when we are doing the bit stuffing, this will change, the bit original pattern will obviously change. Now address field, next one is the address field, identify the secondary station that transmitted or is to receive the frame. So address field is basically for identifying the secondary secondary station, okay, that had transmitted or is receiving the frame. That is for your address field, the next field after the flag field. Okay, so next is your control field. The first one or two bits are used to identify the type of frame. Now what kind of frame, as I have already told, I frame, U frame. So this particular frame, what kind of frame is that? That control field will identify what kind of frame is your particular frame. So that is for the first one or two bits are used to identify the type of frame. It defines now three kinds of frame. I have already told: information frame, I frame, okay, that carry data to be transmitted for the user. It is carrying the data which is to be transmitted for the user. Okay, now flow and error control data, it is controlling the flow and error control purpose, as we already know that this particular whatever things we have studied till today, the particular protocols or ARQs, they are for error control and flow control. So here also the basic thing is about to flow and error controlling of data, right? Now using the ARQ mechanism, again the ARQ is coming, so the automatic repeat request, that particular mechanism is there, are piggybacked on an iframe. So flow and error control data using the ARQ mechanism are piggybacked on an iframe. Piggybacking we have already studied, you can see in the different slides, different videos, sorry, there you can see the piggybacking, the different ARQs, everything I have already discussed, so I am not discussing today. So basically this is the information frame which will have this kind of data, that is, it is carrying the data to be transmitted for the user, and flow and error control through your ARQ mechanism, that is piggybacked on the iframe, that is your information frame, right? Now next is the supervisory frame, that is the S frame. This is the second type of frame that is used for flow and error control whenever piggybacking is impossible. If your piggybacking is impossible, at that particular time this supervisory frame will be used, that is used for flow and error control wherever the piggybacking is impossible. Okay, so at that time this S frame is being used. Now unnumbered frame, U frame, that is the third kind of frame, that is used for link management. It is used basically for the link management. Okay, and can also be used to transfer user data. This can also be used for transferring the user data. Okay, and they exchange session management and control information between two connected devices. When two devices they are connecting, at that time the session management, whatever things are being used for managing the session means starting and ending, whatever thing you are sending, the response, getting the response back. So the whole session, that management of the session and control information between the connected devices, whatever informations they are being exchanged, that controlling that particular information between these two devices, that are being in this unnumbered frame, that is your U frame. So three frames, the I frame, S frame and U frame, and now you know the function of all the three, right? So basically these three frames are there in your HDLC. Okay, now all of the control field, pole, final, bit, they have the polling bit and the final bit. It is called pole when set by the primary station to obtain a response from a secondary station. When it is called a pole, okay, when the control field contains two things, the pole and the final. Whenever it is called the pole, when the it is set by the primary station to obtain a response from the secondary station. When the primary station is setting it, it will be a pole. When I will be getting a response from the secondary station, at that time it will known as a pole. Final when set by the secondary station to indicate a response or the end of transmission. If end of transmission, the secondary station is telling you about an end of transmission, it will do a final. Okay, it will give a final bit. Or if the secondary station is indicating a response, okay, at that time also final bit. In all other cases bit is clear. So primary station, when it is setting the bit to get a response from the secondary station, it will be a pole. But then the secondary station, it is indicating a response, since the secondary station gives a response, so it is indicating a response. At that time it will get a final, or otherwise when it's an end of one transmission, at that time there will be a final bit. So these two bits you have to keep in mind, the pole and the final. Pole is for primary station and the final is for the secondary station, in both the cases, for the end of the transmission or for sending an response. For all other cases the bit will be clear, nothing will be there. Okay, so now here you can see that there are four different supervisory frames also. Supervisory frames, there are also four types of supervisory frames. Okay, so receive ready, that is RR, the bit value will be 00, indicate that the sender is ready to receive more data. When bit value is 00, that means the sender is ready, it can receive more data. 00 means it can receive more data. Okay, like this you can understand. When it is 00, the bit value is 0, that means that receive ready, I can receive more, the sender can receive more. Okay, so indicate the sender is ready to receive more data, right? So it is when the bit will be 00. Next, receive not ready, RNR, that is bit value is 01, means no. Acknowledgement, some packets acknowledge some packets and request no more be sent until further notice. So until I am sending you further notice, don't send any particular frame. Acknowledge some packets, you have to acknowledge some packets and then request no more be sent until it had been further noticed. Okay, so it will be for RNR, it is ready, not received, not ready. Okay, reject, REJ means reject when bit value will be 10. Okay, bit value will be 10, at that time it will be reject, REJ. Request immediate retransmission starting with NR. Here immediate retransmission will be requested starting with NR. Frame check sequence field. Now last one is selective reject, that is your SREJ. Selective request means some selective portion will be rejected, that is bit value will be 11. Request retransmission of only the frame, particular frame which is been requested, that particular frame had to be retransmitted, that is NR, that is your SREJ. Selective reject. Okay, so these are the four types: receive ready, ready to receive. Next is receive not ready, where until noticed don't send any frame. Reject, REJ, where request immediate retransmission starting with NR, where we have to start that particular frame. Now selective reject, REJ, their request retransmission of the selected one, only the frame, particular frame. Now frame check sequence field, from the field where we can check the sequence of the frame, error detecting code calculated for the remaining bits of the frame and exclusive of the flags. Since the flags from starting and ending, they are unique in nature, they are just excluding that particular thing, and error detecting code will be calculated from the remaining bits of the frame, not the flag bits. The flag bits have been excluded, other bits they are taking, and that particular bits will be used for error detecting code. Since the flag bits they are unique in nature, they are just for identifying, they are not for any other, that starting of the your particular frame and ending of your frame, that's all. But after that the other bits are used for error detecting code, calculating the error detecting code. Okay, so this is the main thing about your supervisory frame. Now here you can see type of frame. Here you can see a particular format where you can see the type of frame information, I, supervisory S. So again, name, receive ready, RR, where it is giving receive ready, that means it is ready to receive. Here you can see receive not ready, RNR, reject, REJ, selective reject, REJ. So these are the name. Commands are response, command or response. C by R means command or response, either command or response. Okay, description, user exchange data. Now positive acknowledgement, positive negative acknowledgement. So you can see your data there, where these particular things whatever we have studied till now, these particular things have been used here. Okay, in this concept here I have given this one, so you can see that how they are used. Okay, now the name, again the description, you can see the information is there, that is your information ever ready to receive iframe, and not ready to receive, that is yours. You can see here RNR, so not ready to receive. Here you can see it is receive ready, that is RR, ready to receive iframe. Okay, so here we are ready to receive, the information is also given. Then reject, REJ, there retransmit starting with NR. Select reject register, so retransmit only NR. So here we can starting with NR from that particular with whatever frame we are starting, you have to start with that particular and the sequence, whole sequence up to where the error had been detected. And here what, retransmit only that particular frame which is having any kind of error. Okay, so here you can see the field format, C field format is also given, where 0 1 this etc etc. So this is the particular format where you can see here how we will be using those particular things, the whatever we have studied till now. So your S frame, I frame, each and everything. Mainly the four things you have to keep in mind, that is the RR, RNR and your REJ, SREJ. these things, these are particularly the same things which we have studied: the frame, the selective repeat request, what we have done, the only the frame which is corrupted or which has been lost, that is being retransmitted. But in the stop and wait ARQ or your go back and ARQ, the whole things which were up to the corrupted frame, the whole sequence have to be again retransmitted. So these things you can see here also, same thing here, when reject, so only retransmit starting with that particular frame, and here the selective reject, there you have to only send the particular frame which is erroneous or which is corrupted. Okay, so these things are being done here. Now after this whole thing, I hope that you have understood what is there in HDLC. These all things are there in the HDLC, and this is whatever concept you have studied till now. I hope it is clear that what is our high level data link control. So this particular thing is there in your HDLC, all the frames, about all the frames and different things which is there in HDLC, I have already told you. If you have any kind of doubt, or if you have any section which you want me to explain, you can ask me in the comment section. And I hope you have, if you have got any knowledge regarding this and you are satisfied with that one, then please like, share and subscribe and comment, so that I can know your comments and I can see whatever you want from me. Okay, other topics if you want me to explain, you can say that also, so in the comment section. And if you like my channel, then like, share and subscribe with your friends and others. Till then, take care and goodbye.